Okay, let's dive right in. I want to start with a pretty fundamental question about how artificial intelligence actually tackles problems. When you or I look at a puzzle, we might have a hunch, right? A little spark of intuition. But in AI, it doesn't really work like that. It doesn't guess. It has this super systematic way of exploring every single possibility. And it does this by creating this map, a map of every possible move. We call it a state space. And this simple idea, this map, it's the core behind a really powerful AI technique called state space search. It's how an AI takes a crazy complex problem and basically turns it into a navigation challenge. So, to really get how this map is built, you only need to know three simple terms. Seriously, that's it. These are the absolute building blocks for the whole process.
First up, we've got the state. Just think of it like a single snapshot in time, a picture of the problem at one specific moment. It could be the way the pieces are laid out on a chessboard, or, like we're about to see, the exact amount of water in a couple of jugs.
All right, next up, transition. This one's super simple. It's just the action, the move that takes you from one snapshot to another. It's pouring the water, moving a chess piece. That's a transition.
And finally, the big one, the state space. This is the whole shebang. It's the complete map of the entire problem. It connects every single possible state with every single possible move. It is, for all intents and purposes, the AI's entire universe for that problem.
So here's the key takeaway, right? Once you have this map, this state space, solving a problem for an AI just becomes a search. It's looking for the right path from the beginning, the initial state, to the solution, the goal state. And it uses a specific strategy to search that map.
Okay, enough theory. Let's make this real. We're going to look at a classic riddle that shows these ideas in action perfectly. You've probably heard this one before, maybe from a movie. The famous water jug problem. It's the perfect, simple puzzle to show exactly how an AI explores its map of possibilities to find an answer. Okay, so here's our setup. Each state is just the amount of water in each jug, right? So we'll write it like 0, 0 when they're both empty. That's our initial state. And the goal? Well, it's any state where one of the jugs has exactly 4 liters. Simple as that.
All right, so the map is defined. Now we need a plan, a strategy for how to explore it. So let's pick one and actually watch how the AI methodically charts a course through this state space to find the solution. Okay, the strategy we're going to use is called breadth first search, or BFS for short. Now, the key thing to know about BFS is that it's complete. What does that mean? It means it explores really methodically, one level at a time. And because of that, it guarantees it will find a solution if one exists. And not just any solution, it'll find the shortest one. Pretty cool. So we start at 0, 0, right? Both jugs are empty. The AI looks at this and goes, okay, what can I do from here? And it sees 2 options. I can fill the 3-liter jug, or I can fill the 5-liter jug. Boom. That's the first level of our search tree. And this right here, this is what makes BFS, well, BFS. Instead of just picking one of those paths and running with it, it explores all the options from that first level, both the 3,0 state and the 0,5 state, before it goes any deeper. It's leaving no stone unturned at each level. So it takes a state like 3,0 and asks again, okay, what are my moves now? It can pour that water into the other jug, it can just empty it out, or it can fill the other jug up. And it does this for every single state it's currently looking at, just methodically expanding its map outward, layer by layer. So after exploring a bunch of different paths, level by level, the AI finally lands on this. This is the golden ticket, the optimal sequence of transitions. This path you see here is the step-by-step solution it discovered to get us to our goal, a state where that 5-liter jug has exactly 4 liters. Mission accomplished. Now, BFS is awesome for finding the best solution, but it's not the only tool in the box. There's another really common one called depth first search, or DFS, and it's totally different. It dives deep down one path first to see if it's a winner. It's usually faster and uses less memory, but the trade-off is it's not guaranteed to find the shortest path, and sometimes it can get lost way down a really long dead-end road. So, okay, that was a fun little puzzle, but why are we spending all this time on a water jug problem? What does this have to do with real, powerful AI? Well, here's why. Because the exact same fundamental process, creating a map of states and searching it, applies to problems that are, well, astronomically more complex. Take a game like chess. The estimated number of possible states is 10 to the power of 120.
I mean, that's a number so big it's hard to even wrap your head around. It's more states than there are atoms in the entire observable universe. No joke.
And this technique, the state space search, it's the foundation for tech you and I use literally every single day. It's how your GPS finds the fastest route to work. It's how an enemy in a video game figures out how to get to you. It's how logistics companies figure out the best delivery routes. At the end of the day, it's all about finding the best path through a giant, giant map of possibilities. So the next time you see an AI solve some incredibly complex problem, you'll know the secret, right? It's not magic, it's not some kind of mysterious intuition, it's just exploring a very, very big map, one state at a time. And if this is what the map looks like for a simple water puzzle, just stop and think for a second. What does the map for winning a game of chess even look like?